We can begin. So for this warm up, we're going to start with the table, and the table is illustrating growth or decay. And the only thing that we care about is the base. The base is the number that holds up the exponent, and X has to be an exponent. And so as I look through here, X is an exponent. For this one, X is a base. So it's that one is neither. It's not E, it's neither. And here, X is an exponent. So as long as it is an exponential, you can identify whether or not it is growth or decay, and that's going to depend on the number that holds up the base. No other numbers matter. So for this one, 6/7, that is a fraction. As long as the top number is smaller than the bottom number, that's a fraction that's smaller than 1. So when you have a fraction that's smaller than 1, is that growth or decay? Decay. And just as a reminder, a decay graph looks like that. From left to right, it goes down. This one, that's a decimal. Is that growth or decay?
Oh, sorry. It's growth.
How do you know it's growth? Because it's bigger than 1. It is growth. From left to right, that growth graph would look something like that. From left to right, you grow. Okay, next, rewrite in exponential or log form. You're not solving anything. All you have to know is the placement. So anytime that I rewrite a log, I use the backwards E thing to make it an exponential. So that turns into 8 to the second power equals 64. 8 to the second power equals 64. And whatever this is has to be a true statement. Don't pick an answer that's not correct. 8 squared is 64. That's true. It's good. That's my answer. The next one, it's a little bit more tricky to go from an exponential to a log, but there's a couple of things that I remember. So I first start with log, and then I put an equal sign. And on your quiz, it's multiple choice. So what I would do, though, is cover up the multiple choice, because what I feel like that we sometimes do is we force the answer. Like, figure out the answer and then go find it. Don't force an answer to work just because you look at it, and then you'll make a silly mistake. When I rewrite the exponential as a log, the base of a log goes down by the G, and looking, 10 isn't even over here. What is the base? What is the bottom holding up the number? Is a 49. Jackson, you would be correct that the base would be a 10 if there wasn't any, if there wasn't a number there. Like here, if the 8 wasn't there, that would be a 10. 49. I remember that for a logarithm, the answer to a logarithm is the exponent. The answer to a logarithm is the exponent. So like over here, the answer is the exponent. The exponent was 2. The answer is the exponent. So here, the exponent is 1/2. So the answer to the log has to be 1/2. And then from there, I just have one other number. I have 7. It has to go right here. And then I could use the backwards E thing to double check. 49 to the 1/2 power is equal to 7. So that's the first set of problems. You got to be able to rewrite in either exponential or logarithmic form. And you just got to memorize it however you want to memorize it. The answer to a logarithm is the exponent. That's something to remember. Moving on. However you want to solve these is fine. But one thing that you definitely want to look for are anywhere that you're taking the log of a negative number, because you can't do it. So don't spend time solving it if you can't even do it. So do we have any problems that we're taking the log of a negative number? Yep. We are taking the log of a negative number, and the answer is undefined. So I don't even want to waste time solving it. It's undefined. The other two. One way to solve it is making the base match the base. And there's a really neat trick anytime you're dealing with tens or 1,000, 100, a million. The way that you can rewrite that number, the exponent will always match the number of zeros. And so what's that thing say? What's that say? Okay, I don't think it means anything with my Zoom. I don't know what that was. To rewrite this number, I count the amount of zeros. There's 1, 2, 3 zeros. So that's the same thing as 10 to the third power. So log base 10 of 10 to the third power. If these bases match, and some of you started doing some crazy shorthand stuff on your practice where you were just not writing the log, that's not correct. You have to write the log. And when this base matches this base, they cancel out, and the answer to this logarithm is the exponent. Yeah, but I want to see work. I mean, your quiz is multiple choice, but if you want some partial credit, you got to show me work. The next one, we've got 1 over 16. Well, 1 over 16, can 16 be rewritten as 4 to some power? Yeah, 4 to the second power. So I could rewrite this. I'll solve this one a different way. I could say that this is equal to some exponent. That's the answer to every log. And I'm going to rewrite it. So I'm going to say 4 to some power is equal to 1 over 16. But instead of writing 1 over 16, I'm going to write 4 to the second power. Because we already just talked about that 16 is the same thing as 4 squared. Bless you. To get the 4 out of the denominator, I can do that, but I have to rewrite it, and the exponent becomes negative. So I get 4 to some power is equal to 4 to the negative 2 power. And in this case, whenever this base matches this base, you can cancel these out as well. And the answer is the exponent, or setting the exponents equal. So I get x is equal to negative 2. There is nothing to solve for. The answer is just negative 2. So when you're taking the log of a fraction, you pretty much get a negative number. So that's something to keep in mind. Most of the time you end up with a negative number. The next problem. Hear me out, people. This problem is 8 points. It is 4 points and 4 points. Do not lose points because you don't follow directions. 4 points is for making the asymptote. 4 points is identifying whether it's growth or decay. 4 points and 4 points add up to make 8. Do not lose 4 points because you forget to draw the asymptote. That's the problem. That's part of the problem that's written first. To sketch the asymptote, it's going to be a horizontal line, and it is going to go underneath the graph where it looks like the graph is going to kind of level off. And so this graph, it looks like it is coming down and it's going to level off like this. So it looks to me like that graph is going to have an asymptote right there. It is a dashed line. I put it as solid line just so you could see it. Here, I'll make it dashed. Maybe you can see it if it's dashed. Maybe I'll just make it's bigger. Yes. There we go. If you put a solid line just so that I can see it because you're drawing over the x-axis, I'm okay with that, but it is technically is a dashed line. It's not part of your graph. So sketch the asymptote and then identify if it's growth or decay. So what kind of graph is this? Is it growth or decay? Decay, because from left to right, it's going down. Last, we have expand or condense. On your quiz, it's matching. So there's that little crutch of that you can also use process of elimination to match them up. But as we expand or condense, it looks like these we're condensing, and this one we're going to expand. So here, to condense this, I know that the first thing that I have to look for when I'm condensing is any numbers written out in front, and those numbers I'm going to condense by first taking the number in front and writing it as an exponent. But anytime I have a 1/2 in the front, that becomes the square root. So I will rewrite it. As soon as I don't have a number in front anymore, I can condense it further. And when I'm adding and I condense, those become multiply. I feel like anytime I have a square root and a something else, I feel like that's going to look better to write in front. It's not wrong if you write it as the square root of x times w to the third. That's not wrong, but I just think it's going to look better to write it as w to the third times the square root of x. Again, it's not wrong. If you put parentheses, it's not wrong. If you don't put parentheses, it's not wrong. I mean, it's multiple choice. This is my final condensed answer. The next one, what's the only difference here? Yeah, it's negative. So what's the operation when you are subtracting? Dividing. Okay, well, this one I have to be a little bit more careful. So yes, I'm still going to have to bring this over, and that will become square root. This is still going to become w to the third power. But instead of multiplying, I'm going to divide, and there's a specific order that I have to divide. It'll still be log base 2. Whatever is written first will always go on top. So I'm going to have the square root of x divided by w to the third power. So anything that is subtracting shows up in the denominator. Again, it's not right or wrong if you decide to put parentheses or not. If you like them, put them. If you don't, don't. Next, I'm going to start expanding this. And so whatever is written on top has to be positive. So I'm going to have log base 2 of m. And then anything that shows up in the denominator is going to come after, and I'm going to subtract it. So log base 2 of m minus log base 2 of n, because it's in the denominator, and also minus log base 2 of w. Anything that shows up in the denominator has to subtract. And I don't have any exponents, so I'm fully expanded. Any questions? This was like our conversation like 20 minutes ago. All right, we're done. So you can turn in your warm-up paper and your practice paper. And then go sit down, get ready for your quiz, clear off your desk.